Okay, welcome the second presenter, Dr. Omer from Canada. Please.
What I was saying is good morning, good evening, depending on where you're located. Thank you very, very much to Phyllis and the whole team that was able to invite me to this presentation, where we're going to be talking about VulcanX, where we develop a technology to produce scalable low emission hydrogen at the lowest cost. Okay, here we go. I don't know how much you know about the hydrogen market, but we currently produce about $243 billion worth of hydrogen every year, and it's continued to grow. The main uses of this hydrogen have been ammonia production, oil and gas purification and cleaning, methanol production, and other chemicals. But it's increasingly being utilized for transportation purposes, and what we need is a technology that is capable of producing that hydrogen with the least amount of emissions, because currently it's about 2% of the total emissions are due to the hydrogen production. And that would be the only way to maintain the lowest cost possible. So this is where we come in. We develop a technology that basically is capable of producing hydrogen at the steam method reforming process, which is the main process that is used to produce hydrogen, but with the emissions of electrolysis. The way that we do it is we have a reactor. This is based on methane pyrolysis, and the way it works is quite simple. Imagine a thermos where you put in metals. Then we heat it all up, and the temperature reaches 1,000 Celsius, and we bubble hydrocarbons, natural gas from underneath, and all of the hydrocarbons, they crack, and they become their main components, which are hydrogen as a gas and carbon as a solid. And some of the unique features of our system is that we separated the heating zone from the reactor zone. And by doing this, what happens is that the heat, we can use any sort of heating that is available. So we can use electricity, we can use natural gas, we can use hydrogen, we can use thermal, nuclear, whatever is available on site to heat up our metal. We liquefy it, then we pump it onto the reactor. And because of the constant movement, we prevent one of the biggest challenges that methane pyrolysis has had, which is something called fouling. And basically what it means is that the carbon starts to get deposited onto the walls and reduce the overall production of the reactors, and also it starts to clog it. That's why our system is a fully continuous hydrogen production, and some of our competitors are having these challenges, and because of that, it's more of a batch process rather than a continuous production. And the other advantage that we have in this system is that we designed this reactor and system for scale. And by that, I mean, the only thing that we have to do in order for us to produce more hydrogen or larger quantities of hydrogen, it would be to increase the size of that reactor to a theoretical maximum that we currently have, which is 50 tons of hydrogen per day. That would be a large reactor.
Mr. Herrera.
Yep.
Dr.
Absolutely.
Omar, sorry. I'm one of the audience inside this meeting room, and your presentation is very attractive. However, if you just notice that, can you dismiss the notice from your Acrobat? Yeah. You can
is it showing? Oh, dismiss.
Yeah.
I'm sorry.
Yeah.
Oh, thank you.
Okay.
I really appreciate it.
Thank you so much.
No. So Yeah, so the only thing that we will need to do is increase the diameter of the reactor. We currently have done tests in the lab. That's the one that we're showing. It's at 1 kilogram of hydrogen per day. We secured a lot of non-dilutive funding at roughly about $10 million USD to build that second generation reactor, which is the one that I'm showing here, as well as the one that is behind my my screen. And what we're working on is our next generation reactor, which will require about $7 million worth of investment. And then our next one will be a pre-commercial facility that will be able to produce 1 ton of hydrogen per day. Having said that, we already performed the front engineering design of this 1 ton per day facility, and we are finalizing the details to make sure that we have the right price. And this is specific for North America, but our Asian market would be, I would imagine that will be less for the plants. But of course, your natural gas, especially in Taiwan, is more expensive than it is in North America. Some of the competitors that we have here are related to current technologies, which are electrolysis, steam method reforming with CO2 sequestration, as well as other pyrolysis, methane pyrolysis technologies. I'm just showing a short snapshot because, as I said, this technology makes a lot of sense because it can provide the benefits of the cost of steam method reforming, but with the emissions of electrolysis. That's why, as you can see, there's a lot of competition. And roughly the last time we did an assessment, there were over 45 different companies looking at this. But the interesting thing is that there are many different ways of achieving this process. Basically, you can heat the system many different ways. You can use plasma, you can use different types of reactors, you can use microwaves, hot surface, like, whatever you can think of, you can probably try to increase that temperature and be able to crack those molecules. Our biggest advantage, as I said, is that we designed the system for scale. And with a single reactor, we will be able to produce 50 tons of hydrogen per day. And we are at the lowest cost possible. Right now, we have been focusing more on the North American and European markets, but we're very open and willing to look at the Asian markets because for us it's another region where it makes a lot of sense to use these technologies. As you already know very well, the natural gas transportation, you can just put one of these systems right beside of whatever you need your hydrogen, and you convert the natural gas into hydrogen, and the solid carbon can be used for other purposes. What we currently use it for is we have been enhancing concrete. We have a partnership with Lafarge that is now ITRI in North America, where we have shown that our with the addition of up to 6% carbon content onto concrete, the concrete becomes stronger, lighter, cures faster, and more importantly, it becomes hydrophobic. So water doesn't penetrate into the concrete. We have a very unique team of experts that have now evolved into a team of action-driven engineers and professionals. And under Nader, which is the senior engineering manager, we have a team of 8 engineers that are working towards those next scale-ups and upgrades of the system. We're currently raising $7 million US, and it's basically for providing that jump onto the next generation reactor. And these are the the projections for licensing and royalties technologies. At the end of the day, you have to realize that by the time that we get the contract all the way to where we start producing the hydrogen and we get the royalties, that's where the gap is, and that's why I'm showing projections all the way to 2037. With that, I close it. Thank you very much, and I'm looking forward to interacting a lot more with you.